Create a 3-axis parallel finishing strategy. After completing this video, you'll be able to create a 3D parallel toolpath and identify an optimal cusp height. In Fusion 360, let's carry on with our 3-axis sample dataset and let's explore another 3D toolpath called parallel. Now, parallel has a similar finishing strategy to our 3D contour. However, this does allow us a couple of other options to determine things like the direction of cut. In the parallel strategy, we're first going to explore this with the 1/4-inch ball-end mill. Because we already had used this in a previous operation, but it's no longer used, you can see that it's still in our document settings. However, it doesn't have the black arrow next to it, indicating that it is used in a toolpath. When you take a look at your document tools, you can expand these and see exactly which toolpaths it's being used in, even if those toolpaths are suppressed. So let's select our 1/4-inch ball-end mill, and let's select our aluminum finishing cutting data. Now that we have that selected, let's move on to our geometry. By default, the geometry is going to be based on a silhouette, and we're going to allow it to use the silhouette for the entire part. We're going to leave contact only turned on, and we want to restrict our heights to make sure that we're not going all the way down to the bottom of the part, but instead we'll restrict it to this face. In our passes section, by default, the pass direction is set at 0 degrees. Our step over amount is 0.02 and our cusp height is 0.0016. I'm going to remove some of the extra decimal places off here just to set it at 0.001 and say OK. This allows the tool to go through and remove stock efficiently. One thing that we can notice if we use F7 to hide the toolpath is that the cusps look quite a bit smaller than they did on previous attempts. Now, part of the reason is because of the direction of cut. This doesn't mean that the toolpath is better than using a 3D contour, but in some instances, it'll provide a more efficient cut or a better surface finish. We also have to keep in mind the differences in the cusp height values that we use on different toolpaths. In this case, 0.001 is a very good cusp height for this tool, but it could also be smaller. When we think about determining what that cusp height value is going to be, we have to think about the required surface finish. Keeping in mind that the cusp height is going to leave a small raised section between the different toolpath passes, we need to think about the direction of our cut, as well as the step over amount used between each pass, and determine whether or not that fits in with our required surface tolerances. In this case, let's go ahead and modify our parallel toolpath one more time, and take a look at adjusting the pass direction. I'm going to set this at 90 degrees and say OK. When we set this at 90 degrees, I'll hit F7 to preview the toolpath. Now we can see that the tool is going back and forth in the Y direction, where previously it was moving in the X direction. F7 again to hide that, and if we view this from the front, now we can see some of the micro cusps that we have. Once again, the deviation here needs to be within a required surface finish or surface tolerance. If that 0.001 cusp is applicable, then that's okay. Also note that this does change based on the angle of the face. As we get closer to a vertical face, the cusp height is going to start to spread out, but the height itself will still be the same. As we move over to some of the angled faces, as we start to get into different radii, you can see that the cusp height does vary based on the angle of the face. Once again, these are all factors that we need to consider. With this toolpath, let's right-click and let's edit one more time and select a different tool. In this case, let's go back to using a 1/2-inch ball-end mill and let's double-check our parameters. In this case, the cusp height is now 0.01, but I'm going to set it to 0.001, the same that we had with our 1/4-inch end mill. When we say OK and allow it to generate, we preview this, you can see that the cusp height looks a little bit different, and that's because of the larger radius of the tool. That larger radius will mean that the peaks of these cusps are going to be a little bit different. But once again, Fusion 360 does allow us the option to drive these toolpaths based on a cusp height or a step over value. The best thing to think about is going to be whether or not toolpaths like these can apply to an entire part, or if we should restrict them to certain angled faces or certain areas. Because we've seen that the cusp height and the step over amounts can vary based on the angle of the face, it's often a good idea to focus your attention on certain areas. Let's take a look at one more thing. If we go back into our toolpath and in our geometry section, we disable contact only and say OK. Let's go ahead and hit F7 to turn on the toolpath. As we can see here, when we disable the contact only, the tool is able to extend and go past these sections and allow to cut certain geometry. We're never going to be able to get a rounded tool into this corner. That's something we need to finish with a square end mill. But as we take a look at this toolpath preview, let's go ahead and edit this one more time. And let's select contact only and contact point boundary. When we take a look at this, you can see now the tool is rolling over the edges and around the outside of the part based on the overall height that we gave it. That contact edges is allowing the tool to cut over this edge. If we right click and edit one more time, go back to our geometry and disable contact point boundary and leave contact only, you can see now the tool is not going around that boundary. When we're working with these 3D toolpaths, we have to remember that these toolpaths are model aware. Unless we're restricting it based on a selected face, it is going to be able to cut the side of this based on the overall height of our toolpath. So we need to be very careful about what settings we choose when we're creating our 3D toolpaths. This toolpath is a great option to finish these surfaces, and if we hit F7, you can see that the overall surface finish is relatively good. For this example, I want to make one more change. I'm going to go back to my passes and reset my pass direction to 0, and allow it to generate one more time. Once again, you can see now our cusps are in a different direction, but we are still dealing with the same cusp issue. We're just translating it to a different direction. At this point, let's go ahead and select our Activate option to go back to our Save Name view, and let's save the design before moving on to the next step.